Hello everyone, welcome back. So in this video, we are going to look at today's LeetCode daily challenge, and the name of the problem is house robber. So this is a very interesting problem. So according to the problem statement, in this problem we will be given an array where each element represents the amount of money which is stored at ith house. Okay, so each house has a certain amount of money, and our task is to rob the houses, but there is one constraint. It is that we cannot rob two adjacent houses, because if we rob two adjacent houses, then uh, their security system will send an alert to the police and we will get arrested. So this we can assume. So we will be given an integer array num which represents the amount of money each house is having, and we need to return the maximum amount of money which we can rob without alerting the police. So the police will get an alert when we rob two adjacent houses. So we need to rob the houses without robbing two adjacent houses, and we need to find the maximum amount of money which we can rob. So this was the problem statement. Now let us see the approach to solve this problem. So we are going to consider this small example to understand the approach. Now, first thing that we should understand is that we'll be given an integer array where each element represents the amount of money the ith house is having. Okay. So for each particular house, we have two choices. We can either rob that house, or we have a choice to don't rob that house. Okay. Also, we should keep this in mind that we don't have to rob two adjacent houses, because that will alert the police and we don't want that. Hence, we cannot rob two adjacent houses, and for each particular house, we have two choices to make. So if we are given an integer array where each element represents a particular amount, represents a particular house with some amount of money in it, and for each house we have two choices, then for n houses there will be 2 to the power n choices, and out of that we need to find out the most optimal solution such that we can gain maximum amount of money. Okay, so this is the gist of this problem. For each particular house we have two choices. We can either rob that house or we don't rob that house, and in the given array we need to find such houses which we can rob and which yields us maximum amount of money. Hence, we can easily observe that in this problem we need to find an optimal solution, and for each element we have choices. So we need to make some choices, and we need to find how we can reach that optimal solution. Hence, this observation indicates us that this problem is to be solved using dynamic programming, because we need to consider all the choices, and out of them we need to find the most optimal solution such that it gives us the maximum amount of money which we can rob. So we have seen that we need to solve this problem using dynamic programming approach, but we are not going to directly jump to the DP solution. We are first going to see the recursion, and we are going to look at its recurrence relation. Then we are going to move to memoization, which is also the top-down approach in dynamic programming. And lastly, we will see the tabulation approach, which is also called bottom-up approach in dynamic programming. So this will be our flow. We will start with the recursion. So because recursion will help us to understand the approach of this problem in a better way. Now another thing that I want you to understand is that in the given array of integers where each element represents a house, the amount of money stored in the house at that position. So if we pick a particular house, if we choose to rob that house, we will gain the amount of money stored in that house. Then we need to take two steps, we need to move two steps ahead, I mean to say, because we cannot rob two adjacent houses. And if we rob a particular house, then we are going to move to the next house, and the next house that we will consider will be position of the current house plus 2. Okay, so this was the first part. Second part is that second choice that we have is that we don't rob the current house. Then we can freely move to the immediate next house, which will be position plus 1. So these observations are based on the fact that we are starting our process from the first position in the given array. We can do the same thing starting from the right end of the array, and we can move towards the left end. But here I will start from the 0th index and move towards the right end of the array. Okay, so for each particular house we have two choices. If we pick the current house, the next house which we will consider will be position of the current house plus 2. If we don't pick the current house, we will consider the immediate next house, which will be current position plus 1. Okay, must keep this in mind. Now let us look at the recursive approach to solve this problem. So we will be given an array of integers. Okay, now our recursive something look like this. Consider this example where we are having 3 elements. Okay, so as I said, I will start from the 0th index or the first position. Okay, so let us consider that this fun is our recursive function, and here we are going to pass the first index of our array, which basically tells us that we are making a choice for the house at 0th index. Now here we have two choices. We can either select the house at 0th index, or we don't select the house at 0th index. So firstly, I am going to consider that if I select or rob the house at 0th index, then I will gain one amount as it is as at house at index 0, the amount of money stored is 1. So I am going to gain that, plus as I have robbed the current house, the next house that I will consider will be position plus 2. So current position plus 2, 0 plus 2, we will move to the house at position 2 or at index 2. Now here also I have two choices to make. Either I will rob this house, or I will don't rob this house. So firstly, I will consider that if I rob the house at index 2, then I will gain amount 3, because at house at index 2 is having amount 3 stored in it. So I will gain 3, plus I will make the function call to the next house, which will be current house plus 2, because I robbed the current house. Okay, so next function call will be at 4, but here we are going to hit our base condition. Why? Because the size of the array is 3 and we have exceeded the size of the array, and this is basically our base condition. So whenever we reach our base condition, we are going to return 0. So 0 will be returned. So here it will become 3 plus 0. So from here 3 will be returned. Okay, so I will write it. So if I rob the house at index 2, then the maximum amount that I can gain is 3. So 3 will be returned. Next choice that we have is that I don't rob the house at index 2. Then I will make a function call to the immediate next house. So I will increment position plus 1. So this will again hit the base condition, as you can see, because we have exceeded the size of the given array. Okay, so the last index in our array is 2, but here in this function call we are passing 3, hence this will this will end up in our base condition, and it will return 0. So from here we will get back 0. So out of 3 and 0, we are going to consider maximum only. So here we are going to take 3. So now 1 plus 3 will give us 4, and 4 will be returned back. So now this means that if we rob the house at index 0, then the maximum amount which we can get is 4. So from here we got 4. Now the next choice that we are having is that, what if I don't rob the house at index 0? Then we are not going to gain any amount, plus we are going to make the function call, recursive function call to the immediate next house. So this will be the next function call. Now here also we have two choices. We can either rob the house at index 1, or we don't rob the house at index 1. If I rob the house at index 1, I will gain 2 amount of money, because house at index 1 is having 2 amount of money saved. So I will gain 2, plus I will make function call to the next house. As I have robbed house at index 1, so the next house that I will consider will be 1 plus 2, because we cannot rob 2 adjacent houses, so it will be 1 plus 2. So the next function call will be add 3, but again this will hit the base condition because it exceeds the size of the given array. Hence 0 will be returned from here. So 2 plus 0 gives us 2. So from here we are going to return 2. Okay, so this is when we rob the house at index 1. Next choice that we have is that, what if we don't rob house at index 1? Then we are going to make a function call to the immediate next house, which is house at index 2. Okay, so here again we have two choices. If we rob the house, we will gain 3, plus we are going to make function call to the next house. So we are going to do current position plus 2. So 2 plus 2, we are going to make a function call at 4. This will hit the base condition and it will return 0. So 3 plus 0 gives us 3. 3 will be returned from this side. If we don't rob the house, at index 2, then we are going to make a function call to the immediate next position. We are going to do position plus 1. So 2 plus 1, we will make function call at 3. This will again hit the base condition and it will return 0. So from this side 0 will be returned. So maximum of 3 and 0 is 3. So 3 will be considered. So this will return 3. Now, so maximum of 2 and 3 is 3. So 3 will be considered, and 0 plus 3 gives us 3. So from here 3 will be returned. And now now here we have 4 and 3. So maximum of 4 and 3 is 4. So 4 is our answer. Now I will recap from this side. What happens is that at index 0, if we don't rob the house at index 0, we are going to move to the immediate next house, and we will make a function call at this house. At this house we have two choices. If we rob this house, I am going to gain 2 amount of money, plus I will make function call to the next house, which will be current position plus 2. So from here I will make a function call to the next position, but this is out of bound, hence this will hit our base condition and it will return 0. So 0 will be returned. So 2 plus 0 I will gain. And if I don't rob the house at index 1, I will make a function call to the immediate next house, which is house at index 2, and again the same process will be done. I hope it makes sense and it was clear. This is the recursion tree for this example. For each particular house we have two choices. If I select a particular house, if I rob that house, I will gain the amount of money stored in that house. Then I will make a function call to the next house. As I have robbed the current house and I cannot rob two adjacent houses, the next function call will be current house position plus 2. This was the first part. If I don't rob the current house, then I will move to the immediate next house, which is current position plus 1. Okay, so these are the choices that we are making, and after considering all the choices, whichever gives us the maximum amount of money, that will be our answer. And in this example, our answer is 4, and it is clearly visible that our answer will we will gain 4 amount of money when we rob the house at index 0, and later if we rob the house at index 2, it will give us 4. This was the recursive approach to solve this problem. Now let us quickly look at the code, recursion code. So here I am calling the recursion function, and here I am passing 0 index. We will starting with the 0th index, and this is our in our function. This is our base condition. When our index exceeds the length of the array or becomes equal to it, it means that we have reached out of bound, and hence we will return 0. Otherwise, for each particular house, we are making two choices. If I rob the current house, I will gain the amount of money stored in that house, plus I'm going to make the next function call, which will be current position plus 2. The next choice that we are having is that if I don't rob the current house, I will make a function call to the next house, immediate next house. Okay. So, and out of these two choices, whichever gives us the maximum amount, we are going to return this. So this is our recursion function for this problem. And if I try to submit this, let us see what happens. It gives us time limit exceeded because as you can see that in our recursion tree, there are repeated subproblems here, and because of which it gives us TLE, because if our array is of size n, then for each house we have two choices to make. Because of that, our time complexity of recursive solution is 2 to the power n, which is exponential, and it is very high, and it will obviously give us TLE. So to overcome this time limit exceeded, we can use memoization, which is the next part. So to memorize this recursive solution, all we need to do is store the output of the subproblems which we have already solved. So for that, we will do this. We are going to use a memo object which will store the output of the subproblems which we have already solved. And whenever we return back to that subproblem, we are going to check if that problem is already solved or not. If it is already solved, it will be present in our memo object, and we are simply going to return it without again calculating the answer for that subproblem, which will save time. Okay. If I in memo, we will return memo of I. Okay, so if we return back to a position whose output is already calculated, we are simply going to return the output of that position, because we will only store the optimal output. Okay, so we are simply going to return that output. If that position is not calculated previously, we are going to calculate that position, the output for that position, and we are going to save it in our memo object, so that the next time when we get that position again, we don't have to calculate its output again. And the time complexity of memoized approach will be big O of n, because for each particular house we are calculating only once, and we need to pass memo object as well. Now let us try to submit this. So as you can see, this memoization approach works, and it got accepted. Now we can also look at the third part, which is the tabulation approach. We have already seen the memoized approach to solve this problem, and the time complexity of memoized approach was big O of n, because for each particular house we are calculating the output only once, and if the next time we get this same, we get a position which is already calculated, we are not going to calculate the output of that position again. We will simply return it from our memo object. And the time complexity was big O of n, and space complexity of memoized approach is also big O of n, because we have used external space for our memo object. Now let us look at the tabulation approach, which is the bottom-up approach to solve this problem. So this is the tabulation solution for this problem. And in this problem, basically, if the length of the given array is 1, it means there is only one house. We will return the amount of money stored in that house. Otherwise, we have initialized this DP array, and initially it is having elements same as the array given to us. Then we are initializing the element in our DP table at index 1, which will be maximum of the first two elements in the array given to us. So basically, I would like to mention that DP of I basically tells us the maximum amount that we can gain, till index I. So maximum amount that we can gain till index I will be stored at DP at index I. Okay. After that, we will iterate, we will use a for loop and iterate from the second index, and for each particular index we are storing the maximum of the amount of money at the current index plus DP of I minus 2, which is the day, which is 2 days before the current day, and second is the maximum amount which we gain till the previous day. So whichever is maximum, we are going to store it in the current position in our DP table, and at the end our output will be stored at the last element in our DP array. And if I submit this, it should get accepted. So as you can see, this solution is also accepted. So the time complexity of tabulation approach is linear, because we are simply iterating through the given array once, and the space complexity is big O of n, because we have used another separate array for our DP array. Okay. So this was the approach to solve this problem. It is a very interesting problem, very standard dynamic programming problem. So I hope it was clear. So this was it for this video. Thank you.